and welcome to Algebra 2 with Mr. Clausen. Today we're going to talk about working with rational expressions. And to get started, we're going to go over some basic simplifying of rational expressions, things that you're probably familiar with to some extent, and then look a little bit further into multiplying and dividing by rational expressions in this given video. And so to get started, one of the things I want to talk about is, let's say you have a basic monomial in the numerator and a basic binomial in the denominator. You probably understand that if you have y over y, those cancel and give you a 1. You know, if you have x to the fourth on the bottom and x to the third on top, you know, you can go and cancel out like terms, so there'd be 1x left. And you probably also understand that, you know, 27 is equal to negative 3 times 9, so we can cancel these 9s. And you can take larger, more dense rational expressions like this and then rewrite them into these simpler, easier to digest variations. And this is really nice if you are trying to do a calculation, and if you can eliminate a variable entirely, that is a really sweet thing. And that happens sometimes. You know, I was actually just going through some stuff on quantum mechanics, and you know, there was an exercise where I believe it was Maxwell Planck was actually trying to, you know, figure out if there was such a thing as a minimum energy, and he actually introduced a variable to see if it would just kind of cancel out at the end. And what he found is that there was a small constant left, which is actually what is known as Planck's constant today. So it can be a really useful exercise, and sometimes, you know, introducing that variable to see if something's actually the case or not can be really useful on various applications. But this is the kind of example that we're looking here as far as being able to go through some of these. Now, to ramp up a little bit of what we're doing in this chapter, we're looking at a lot more situations where there are binomials and trinomials and those type of things in the numerator. So what we have to do is we have to go and factor things out. So for example, and if we factor out a 3 here, we'd get x minus 2. And I think you can see, you know, if we go 3 times x, we'll get 3x, and if we go 3 times negative 2, we'll get negative 6. All right, and just kind of think about it that way. As far as this other trinomial down here, a is equal to 1, so we can just simply look at the factors of 8. So if we go negative 2 times negative 4, I'm just going straight to it like we did in chapter 5, you know, when we were looking at the basic of quadratics and just some of those basic factoring tools. And I can see that if I add these two together, I'd get the 6. So I can simply rewrite this as x minus 2 times x minus 4 in a very simple derived out situation. And with something like this, you know, we can rewrite this just for simplicity's sake of 3 times x minus 2 all over x minus 2 and x minus 4. And one thing I just want to point out here is, since we have x minus 2 in the numerator and the denominator, and everything's being multiplied together, right? Very key thing is there's not addition and subtraction going on here right now outside of the parentheses. So we can go and cancel this, and then this more elaborate function becomes 3 divided by x minus 4. A simple trick in terms of simplifying these rational expressions. Now, the last one here, we're going to do a similar type of situation. You know, so again, I see negative 2 and negative 3. So this is a pretty easy to deduce situation here, where we have something that looks like this. And then on top, you know, I'm going to try to split that apart a little bit. If we go 2 times negative 2 and we use the AC method, this will give us negative 4. And if we look at the factors of negative 4, you know, I could go 1 times negative 4 and figure out how to split that apart. All right, so we reviewed this in the last video, but if you're still not quite there yet, it's something you're going to need to keep working on a little bit. And if you need to go back to, you know, the unit on quadratics, you know, there's some videos there that you can watch to review that. And what we can do here is we can just say 2x squared minus 4x, and then we can say plus x minus 2. All right, so watch that when you're going through and trying to figure that out. And so what I'm going to do here is I'm going to pull out 2x from both of these terms. This will give me an x minus 2 left. And if I pull a 1 out, theoretically, on this other one, I'll get that as well. And so we'll loop that down here, and we'll say 2x plus 1 all over x minus 2. And then in the denominator, we'll put this guy over here, and we'll say x minus 2 times x minus 3. And so that's a big thing that we're looking at in this specific video is, how do we take some of these basic skills and look at, things where there's really multiple functions kind of being applied here and simplify them out into these new variations like 2x plus 1 all over x minus 3 from this larger, more convoluted example. And so with that, we've gotten some basic, skills involved here. Now, multiplying rational expressions. Now, you might think this is just as simple as just plug and chunk and crunch everything through. But one of the things that I want to make careful note of here is that before you start multiplying rational expressions and just plug and chunk it everything, is you want to go and make sure things don't cancel out first. Because first of all, this is a relatively large example, and you're going to have to cross multiply and FOIL and all this stuff. And I can just about guarantee you by the time you get to the end of all that, that it is not going to be in its simplest form. And that's a very key thing that you want to take advantage of here, is you want to have things in its simplest form. Chances are, if you can get things to its simplest form, there is a slight chance that you might be able to identify a relationship, like if you want to figure out Planck's constant or something of that nature. And so we need to take careful consideration to that. And one of the things that we can do is we can simplify every term where it's at and just make sure nothing can be canceled before you start multiplying everything across. That way, if you make sure everything is canceled by separating everything apart and making sure nothing is present, then once you do all that work foiling everything, then it's in its simplest form. So let's try this. So we have a difference of squares here. So we have an a minus 2 and an a plus 2 situation from this term here. So very key to look at. And this is actually a difference of squares down here as well. So this would be a minus 1 times a plus 1. And here we can factor out an a, and we can go and split this apart into a times a plus 2. And what we're going to see is we're going to see a little bit of overlap. So if is there something that is both in the numerator and the denominator? Well, I see that this can go and cancel with that. Huge simplification right there. And then we also see that that can cancel out with that. Again, another huge simplification. Now, with that said, with just that one multiplication that happened there, a minus 2 is now the only thing that is in the numerator of this expression. Simplified this whole process dramatically by just taking those couple extra seconds and doing that. Because if you convolute all this stuff together, well, what you're going to be doing is factoring out all these terms that you just multiplied together, unless you just had no intention of simplifying the expression to begin with, which I guess is fair. But in these examples, I want you to be able to simplify completely. So now in the bottom, these two terms cancel. So now all you have left is a times a minus 1. Well, that's not that bad to do. So we can go a times a minus 1. And if once it's completely simplified, you can write it that way. If you want to finish the multiplication, I suppose you could go and write it like this and say a squared minus a, and you could go write it that way as well. But I think this is a perfectly legitimate answer, unless this says to approach it differently. But multiplying the expression doesn't necessarily mean just clumping it all together and making it more complicated. Many a times you can go look through it and see if there's anything you can whittle out first. And again, we took something that looks a little scary and convoluted and really simplified it down to one of these two expressions by taking advantage of some key properties. Now, the last example that I'm going to go over is just simply dividing rational expressions. And now, you might think of dividing rational expressions and just go and flip this second part and then apply multiplication. And you know what? You can totally do that in this instance. So, if you are not familiar with that or you've kind of forgotten, that's all right. We'll walk through this again. But before I get to that point, I'm actually going to do some factoring and just make sure everything's kind of separated out, because I think that's going to make it a little easier. So again, difference of squares here, 16 is the square, a squared is the squared. So a minus 4, a plus 4. So we got these two guys separated out. There's a common factor of 3 here. So now we have a minus 4. All right, a minus 1 here. And then if we go negative 3 and 5, those two factors added together give you the positive 2. So then you'd get a minus 3 and a plus 5. Okay, so we just, in a very short amount of time, you know, if you need to refresh on this a little bit, that's fine, you know, but we got to a level where we were pretty proficient in this beforehand. So now what I'm going to do is I'm just going to rewrite this here. I'm going to go the a minus 3 and the a plus 5. And just to show a little work here, and then go the a minus 4 and a plus 4. But now, since it's division, just remember, all you need to do is flip the numerator and the denominator in this situation. So now we'll go the 3 times a minus 4, which is the 3a minus 12, all over the a plus 1. All you need to do is flip it, and then you're changing division into multiplication. And now we just go, cancel like terms. That's going to be the only thing that cancels. And now, yeah, there's a little chugging through here. So now we got to FOIL this back together. That ended up being kind of a pointless cause. But, you know, it's something that you need to do, because if there was an a plus 1 or an a plus 4 there, that took me seconds to just do that and then just go check it. So now we can go 3 times that entire expression. So that'll be 3a squared plus 6a minus 45 all over a plus 1 times a plus 4. So that would be a squared plus 5a plus 4. And now you would have this new expression that would come out as a result. So pretty simple video today in terms of basic operations with rational expressions. I got a nice little homework set here to just make sure that we're up to snuff on all those different skills and all those different factoring applications. So hopefully this video gave you a nice breakdown of how to go and approach all those. And with that said, let's do some math.